A radical expression contains a radical sign. These signs look something like this. The part of the expression under the radical sign is called the radicand. For can be written with fractional exponents, and sometimes this is desirable. For example, or we can have the 4 in the v of the radical is equivalent to the fractional exponent 1/4, and so this is equal to 2 to the 1/4, x to the 2/4 or a half, and finally y to the 3/4. The order of the radical or root, except for the square root, is indicated by a small number written in the v of the radical sign. So the order of the radical is indicated here by the 3 and here by the 5. Here, where there is no number, it is understood to be 2. This small number also is referred to as the index. So the numbers in the v of the radical sign, which represents the order of the root, is also called the index of the radical. So the index of this radical is 5, the index of this radical is 3, and of this one is 2. An entire radical expression has all terms or factors under the radical sign. All of the expression is under the radical sign. All of these examples are entire radicals because all of the expression is under the radical sign here, as you see in every one of my examples. A mixed radical is an expression with factors outside the radical sign, such as in. Three square root 5. 4 fifth order root of 8. 8x squared, fourth order root of 6xy cubed, and so on. Notice that besides the radical expression itself, this part here, there's a number outside of it. Of course, the whole thing is a radical expression, but we can see that this is a mixed radical. Radicals that are multiplied separately may be multiplied together under one radical sign. There is one proviso regarding that statement. The index of the radicals must be the same. For example, the square root of 3xyz multiplied by the square root of 2x cubed y multiplied by 7xyz squared. All have the same index, which is equal to 2. Consequently, we can express this under one radical sign in the following way. 3 times 2 is 6. 6 times 7 is 42. X multiplied by x cubed multiplied by x is equal to x to the 5th. Y times y times y is y to the 3rd. And finally, z here multiplied by z squared there is z cubed. Another example is 7 square root 3 multiplied by 2 square root 2 multiplied by 3 square root 7. Notice this, in this example, I have mixed radicals in the problem. Well, we'll take the parts of the factors outside the radicals and treat them separately and look at 7 times 2 times 3. And under the radical, we have 3 times 2 times 7. This then can be simplified, and we can write 42 square root of 42. We can also, when dividing by separate radicals, write the entire expression under one radical sign. Here's an example. Let's take the cube root of 12x cubed y squared and divide it by the cube root of 2xy. Notice that once again the procedure will apply only if the index of both radicals are the same. If they are, this then is equivalent to the cube root of 12x cubed y squared over 2xy, the fraction under the radical, or the radicand, can be simplified here. And we end up with 6 x squared y as the simplified version of the given problem. A radical expression is in its best or simplified form if the radicand does not contain powers whose exponents are simple multiples of the index. Now here's a statement that we want to pay careful attention to regarding simplifying radical expressions. Note, a radical expression is in its best or simplified form if the radicand does not contain powers whose exponents are simple multiples of the index. If factors of such powers occur, the radical can be changed to a mixed radical expression, and that's what you must do. Here are some examples. The square root of 12. Now, the square root of 12 is equal to 4 times 3. Notice, first of all, that the index of this radical is 2 and that 4 is a square. In other words, this is equal to the square root of 2 squared times 3. And the square root of 4 is 2. So what this amounts to then is a mixed radical, which is the best form of the entire radical that we started with. It will take some practice to get used to this conversion. So let's do more examples. We have the square root of 12x cubed. Now, determine powers which are factors of the radicand whose exponents are simple multiples of the index. Well, 12x cubed contains a 4 and an x squared. Put 3x in there as well. So this is then equal to the square root of 4x squared multiplied by the square root of 3x. We would rewrite this in its best form as a mixed radical, 2x, the radical sign is gone, followed by the radical sign and 3x. Let's try another example, but this time we will use a different index. The cube root of 48x cubed y to the 6th z squared. Can you find powers in the radicand whose exponents are simple multiples of the index 3? Well, we certainly can, because 48 contains 2 cubed, and 3 is a simple multiple of the index 3. Similarly, x cubed, similarly y sixths. Powers which have exponents that are simple multiples of the index have to be removed from the radicand in order to express the radical in its best form. The rest of it is, of course, made up of square root of 6. I'll put the square root of, or at least a cube root, I should say, of this part here now and of this part y, but we do have z squared left over. There's no simple multiple of the index in that exponent. Of 8 is 2, the cube root of x cubed is x, and the cube root of y squared is y squared, followed by the cube root of 6z squared. The next topic is on addition and subtraction of radical expression. Like radical terms are terms with identical radical factors, or identical radicand parts. Like radicals can be added or subtracted to simplify the expression. For example, 3 root 2 plus 7 root 2. Here are like radicals. The radicand part of this one is exactly the same as the radicand part of this one. And the sum of these two is equal to 10 root 2. Another example, let's take 2 root 7 minus 4 root 3 plus 2 root 7 plus 2 root 3 minus root 7. There are several like radicals in this expression. Here is root 7, same radicand as this one, which is root 7, and this one, which is also root 7. So those three radicals can be added or subtracted, whatever the case may be, to simplify the expression. 2 plus 2 is 4, subtract 1, amount to 3 root 7. And that amounts to minus 2 root 3. One more example that you will have to be very careful with is the square root of 50 minus the square root of 32. Might seem as though the expression cannot be simplified further. But the square root of 50 is not in its best form. Neither is the square root of 32. Simplifying the square root of 50, look at square root of 25 times the square root of 2. Now look at the square root of 32 and notice that it also has a factor that's a power whose exponent is a multiple of the index 2, and that is the square root of 16. This then is equivalent to 5 square root 2 minus 4 square root 2, and this amounts to simply 1 square root 2, or simply, the next topic is division by radicals.